Hey there, welcome to Make Anything. I'm Devin, and lately you may have been seeing more and more of those really cool time lapses that just seem to grow out of nothingness. They're super smooth, they look wonderful, and I've been doing it a lot lately. Other channels have been doing it as well, although my technique's a little bit different than what most probably do, and I've been getting a lot of questions about how it's done. So today I'm gonna reveal the secret. We're gonna hack the system. Let's do it. If I run the defrag and the disk cleanup at the same time, okay, maybe that's not exactly how things are done, but you know, I had to have that spicy intro to hook you in. Still, the actual process is pretty cool, so stick around and I'll show you how things are really done. I'm keeping these though. These are cool. Cool. Alright guys, so I switched to my wide angle lens so that I could show you guys my actual setup. Before I go through the whole process of how I got to this end result, I just want to show you what I'm working with now. To do that, we're gonna have to go back to this little tiny dark corner of the print shop where I've got my setup inside of this mysterious black box. So first off, I'll just say that the way that a lot of people are doing these time-lapse photos is using a script called Octolapse, which just left beta, and that's part of Octoprint, which is this system that runs on Raspberry Pi and other small computers that lets you run your printer wirelessly through the internet and lets you manage your prints remotely, stuff like that. But I wanted to come up with a more physical solution, and I think it's pretty interesting. So maybe we need to get some lights on in here. All right, I've got this big old bright light up here now so that I can properly show you this space. The reason everything is black and dark is because the idea is to have the most controlled environment possible. That way there's not a bunch of flickering when we're taking our time lapse. So I made this dark space so that I can try to get a consistent light. The next best thing, or the very best thing, would probably be to have a dedicated closet where nothing touches or looks at this print as it's going. But for now, this is the best I can do. I've got some foam up here blocking the light from outside. I've got just black foam core all around, and I'll show you how I built that in a bit. But basically, we've got the printer in here. The filament is feeding through a tiny little hole, and there's the magic. As you can see, I've built this little rig. It's a finger built with flexible filament, and it literally just presses this remote shutter, which is connected to this camera, which is taking the time lapse. So instead of having some kind of program take the photo, the printer is physically pressing the button here and causing the photo to be taken. So all that takes is a little bit of G-code so that between every layer, it moves over and takes the photo. Other than that, it's just a couple prints here to make it all line up and work out. Yeah, it's that simple. It really is. So I guess we'll go ahead and now look at all the work that it took for me to get here, because I started step by step. That's how I tend to do it. Iterative design. Hold on. Oh no, this is upside down. Okay. Let's do the next thing. So after measuring that remote trigger for my camera, as well as the part of the printer that I wanted to connect it to, I modeled this little connector piece, and I basically wanted it to be a part that I could snap into place without having to have any extra hardware. The first version didn't fit quite right, so here's version 2.0. As you can see, I have this little built-in spring so that it holds onto the camera shutter nice and tight, and I've also got this kind of springy clip to connect it to the side of the printer here. So this one snapped on, and this one was for my CR10. As you can see, it works quite well. The shutter just slips right into place. The button is accessible. So the next task was to print the little finger that would connect to the print head so that I could use that to press the shutter. here's that part, and I made it to connect to the cooling fan. So I'll unscrew that, and well, I didn't design this so well, so I needed to drill some little holes so that I could actually access the screws. Let's screw that back into place, and in the meantime I was printing this flexible little finger using Filamentum's Flex Fill filament. So we'll just peel that right off. Perfect print, first try, and we can slip that onto my little PLA part. And there we go, boop. The idea is that this flexible little finger will give way a bit so that it doesn't break the plastic parts, although I did have to reprint this holder a couple times to really get something that was sturdy. So in the end I ended up coming up with a solution that used one of the screws that's already on the printer to really hold it into place. This one right here was pretty much my final design. I probably went through 5 or 6 different versions. Now I just need to figure out the exact position that I need the print head to be in order to take a photo. So I'll start by homing the printer to bring it to 0, 0, and then I'll go ahead and use the move axis command and slowly adjust the X coordinate until that finger just presses the trigger enough to take a photo. Right about there. Alright, I tested that a few times for consistency and it worked out. So in this case, 232 was the exact number I needed. Here in Simplify 3D, I made a special profile for this time-lapse setting, and here are my general print settings. You can copy these down if you've got an Ender 3 and want decent prints, but what we're really going to focus on is this Scripts tab, and specifically the Layer Change script, which lets you inject some G-code in between every layer. So the first line is a G90 command, which basically sets the printer to using absolute positioning instead of relative positioning, which basically just means down here when I say X220, it's going to move to that specific coordinate rather than moving an extra 220 compared to where it already was. I think that's just default, but I did it just in case. Next we've got a G1 command, which is the move command. We're moving to X220 and Y215 at a feed rate of 9,000 millimeters per second. So that's going to quickly move to the general position we want it to be. And then we'll do another G1 command just to move that X a little bit further to actually press the button on the trigger, a little bit slower. From there we'll use the G4 wait command and have it hold that trigger button down for 700 milliseconds, and then it's going to go ahead and move away. After it completes these commands, the printer will just move right back to where it needs to be to start the next layer. It's really cool. Now this isn't Simplify 3D. I understand not everyone wants to pay for that slicer. So in Cura, I believe you can do it by using this post-processing plugin. I'm not exactly sure how it's done, but I guess you would go into search and replace, search for some command that's at the end of every layer, and then replace that with the same command plus all those movements that I just showed you. If anyone has a better idea of how to do this, please let us know in the comments, and that would be very appreciated. But for now, I'm just using Simplify 3D. So here I am printing my caterpillar with that layer change script, and as you can see, it'll move right to place, take a photo, and then move right back and continue working. It'll do that layer after layer, and then the end result is all these photos that you can stitch together to create that really awesome time lapse. This was only my second time lapse using this technique, so my settings were still a little bit off. I had some stringing and I kicked the tripod a couple times, but overall everything worked the way I was hoping, so that was awesome. Now that I had the time lapse figured out, I just had to build that special space so that I could get more consistent photos. So I decided to use this little corner of the shop, set things up, and then started measuring my space to figure out what I need to build. Once I had those measurements, I used some old foam core that I had laying around, and I just have these 3 panels that are locked into position using these little end caps that I fashioned using more foam core, and that creates the general structure. So I slipped those panels into place. It was a really nice and tight fit. I didn't actually need those corner pieces. And then I also slipped another piece of foam core underneath so that the bottom was black as well. Now I'll just go ahead and plop the printer down, plug everything in, and then I poked a hole in the side with a screwdriver. Ooh, ooh,
Yeah, just some magic there. Anyways, that's gonna let me feed the filament in without letting any light in. So it's just a little tiny pinhole, and that's gonna save me some space as well, since I don't have to actually fit the filament inside of my box either. Finally, I wanted to use an LED strip I had lying around to create some nice lighting effects. So I cut these slots into the foam core so that I could create a nice little temporary way to attach this LED strip. One more in the middle to hold it into place, and that was pretty nice. And there we go, we've got our own little color customizable light box. From there, it was just a matter of doing some more time lapses and really just fine-tuning my camera settings, as well as my print settings to account for that print head moving around a little more than it normally would. Here's my very first time lapse. This one was actually when I was still using the CR10, and you can see it's really flickery, and that's because I wasn't using manual settings on my camera. So I realized right away that I had to switch to manual photography. Here are a couple of my retro sphericons that I did after the caterpillar print. You can see there's still a bit of stringing, but overall I was definitely improving quickly. This is what I call spin fill. It was a really crazy print, but it was basically made for this technique of time lapse, just to look really cool. And then after that, I did my VR sculpted coral reef. And here you can see that I've definitely gotten further with my retraction settings. The print was pretty clean, still could use some work, but it's definitely getting closer and closer until the one that I just finished today, which was this cell vase. This one was also pretty much designed for the sake of making a cool looking time lapse, and I would say I pulled that off. Well, there it is. That's my technique for making these really cool time-lapse videos. I've been so eager to share this with you because I think they look so cool, and the more awesome time lapses there are out there, the better in my opinion. So I'm excited to see if you guys modify my technique to work with your own printers and with your own cameras, but that's up to you. So until next time, I'm Devin. This is Make Anything. Don't forget to stay inspired.